Look up tonight. Find that pale smear of light across the sky. Your brain is going to do something automatic. It's going to file it away as beautiful, harmless, distant, something to photograph and forget. That instinct is the most dangerous lie your mind has ever told you, because that band of light isn't a view. It's a wall, and in the next 20 minutes, you are going to understand exactly how permanent that wall is. Not because our technology is primitive, not because we haven't tried hard enough, but because the universe itself wrote the rules and then made sure we could never win by them. This is not a video about hope. This is a video about the exact, brutal, mathematical truth of what it would take to cross the Milky Way, our galaxy, our home, our prison, from one end to the other. And the answer does not just describe a distance, it describes a limit, one that compounds at every turn, crushes every solution, and ultimately forces a question so uncomfortable that most science content refuses to ask it. Stay with this. Because the numbers alone won't shake you. What will shake you is what the numbers do to everything else. On the clearest night of your life, in perfect conditions, far from any city, you can see roughly 3,000 individual stars with your naked eye. That feels like a lot. It isn't. Our galaxy contains somewhere between 100 and 400 billion stars. What you see with your best possible human vision represents less than 1 millionth of a single percent of what is actually there. The rest are hidden. Too far, too dim, buried behind walls of gas and dust so thick that even our most powerful space telescopes cannot see through them completely. The Milky Way is a spiral galaxy. It rotates. It has arms that curl outward across hundreds of thousands of light years. Right now, at this exact moment, our solar system, the sun, every planet, every moon, every asteroid, everything we have ever launched into space is sitting about 25,000 light years from the galactic center, embedded in one of the outer spiral arms, being carried around the core at roughly 515,000 miles per hour. That is not something we chose. That is simply where we are. And even at that extraordinary speed, one single orbit around the center of our own galaxy takes approximately 225 million years. In the entire history of the human species, we have not completed a single lap, not even close. The dinosaurs didn't complete one either. In fact, the last time Earth was in the same position in its galactic orbit that it occupies today, the first dinosaurs were only just appearing on the surface. That is what we are talking about crossing. Before we go any further, if this is already rewriting something in your mind, hit the like button. It helps more people find this, and frankly, more people need to sit with these numbers. Now, let's try. Let's be as generous as physics will allow. Voyager 1 was launched in 1977. It has been moving through space for nearly 50 years. It is the farthest man-made object from Earth that has ever existed. It moves at approximately 37,000 miles per hour. At that speed, aimed directly across the Milky Way, traveling without stopping, without failing, without a single course correction, it would take approximately 1.7 billion years to reach the other side. Not million, billion. The Parker Solar Probe is faster. It uses the sun's gravitational pull as a slingshot, looping tighter and tighter until it reaches speeds of up to 430,000 miles per hour. The fastest object human hands have ever built. At that speed, the crossing takes approximately 300 million years. 300 million years ago, the first dinosaurs hadn't appeared yet. The continents looked nothing like they do today, but there is a problem nobody mentions when they quote that number. The Parker Solar Probe only reaches those speeds by falling toward the sun. In open interstellar space, there is no star to slingshot around. There is nothing pulling you forward. Whatever speed you launch with is the speed you keep, unless you are burning fuel to accelerate, which means carrying that fuel, which means more mass, which means more fuel required to push that mass, which means still more mass, and the problem compounds before your ship has left orbit. That 300 million year estimate is not a ceiling. For a ship traveling under its own sustained power through empty space, it is the optimistic case. The real number gets significantly worse, so we go faster. We go to the absolute boundary of what the universe permits. The speed of light, 299,792 kilometers per second. Nothing with mass can reach it. This is not an engineering limitation. This is not something we will one day overcome with better materials or smarter computers. It is a statement written into the structure of reality itself. The energy required to accelerate even a small ship carrying human beings to the speed of light exceeds all the energy in the observable universe. Every star, every black hole, everything. It is not enough. But let's be generous. Let's say we somehow achieve 99.9999% of light speed. Something strange happens. Einstein's special theory of relativity tells us that the faster you move, the slower time passes for you relative to everything else. At that velocity, the factor by which time slows is approximately 700. For every 700 years that pass on Earth, 1 year passes on the ship. Apply that across the full 200,000 light-year crossing, and the crew experiences roughly 285 years of travel time. Not 200,000, 285. On paper, this almost sounds manageable. It isn't. Here is why. To reach that speed, you need fuel. As the ship accelerates toward light speed, its effective mass increases. The more mass, the more energy required. The closer you get to light speed, the more each additional fraction of a percent costs, not in a straight line, but on a curve that bends almost vertically near the top. The fuel required doesn't double or triple. It grows toward infinity. No known energy source in the universe produces what you would need. Assume you solve the fuel problem. You now face the radiation. Interstellar space is not empty. It contains hydrogen atoms, the most common particle in the universe. At the speeds we are discussing, a single hydrogen atom strikes the front of your ship with the energy of a high-powered rifle round. Not occasionally, constantly, every second of the journey. A grain of sand hits with the force of a nuclear weapon. Any shielding dense enough to stop this is too heavy to accelerate to those speeds. Any shielding thin enough to accelerate becomes degraded over centuries of constant particle impacts. And it fails in the middle of interstellar space where no repair is possible and no rescue is coming. There is also the light itself. At near light speed, photons from stars ahead of you are blue shifted, compressed upward in frequency. Visible starlight shifts into ultraviolet, then X-rays, then gamma rays. The front of your ship becomes bathed in radiation that kills unprotected crew within minutes. You cannot fly fast enough to survive, and fast enough to arrive within a human lifetime at the same time. The physics forbids it. But suppose you solve the radiation. You solve the fuel. You build the ship. Who goes? And what happens to them? 285 years of ship time means more than 10 human generations. No one who boards that ship will be alive when it arrives. The people who step out on the other side will be the descendants of the people who stepped in, separated from the original crew by great-grandchildren who have never seen Earth, who were born inside metal corridors, who inherited a mission they never chose. By Generation 3, the crew has no living memory of what they left behind. By Generation 5, the history of Earth exists only in whatever records the previous generation managed to preserve accurately and pass down without distortion. Cultures shift, priorities change. What begins as a mission of exploration could, after 2 centuries of total isolation, become something the original crew would not recognize. And while those 285 ship years pass, 200,000 years pass on Earth. Every person who watched the launch is dead within decades. Every government that funded the mission is gone within centuries. The entire recorded history of human civilization, agriculture, empires, revolutions, moon landings, everything fits into less than 5% of the time that passes on Earth while the ship is still crossing. The civilization that sent them no longer exists in any recognizable form. There is no mission control. There never was. Not really. Radio signals travel at the speed of light. At near light speed, transmissions home fall so far behind the ship that replies from Earth take almost as long to arrive as the journey itself. From the very beginning, the crew is alone. Completely, permanently, irreversibly alone. And that brings us to the detail that almost no one discusses. There is a point in this mission, reached surprisingly early in the journey, where the energy required to decelerate, reverse course, and return to Earth exceeds anything the ship physically carries. Before that point, returning is a decision. After it, returning is no longer possible. Not difficult, not expensive, impossible. The mission becomes one way not as a dramatic choice, but as a quiet arithmetic fact. The crew doesn't decide to continue. They simply discover they cannot do anything else. Now, here is what this all means for the question that generates more debate than anything else in space science. People see lights in the sky. Governments hold hearings. People genuinely believe that beings from other star systems have traveled to Earth and are moving through our atmosphere undetected. Here is the physics of that claim. The nearest star to our Sun is Proxima Centauri, 4.2 light years away. At the speed of the Parker Solar Probe, the fastest thing we have ever built, that journey takes approximately 6,000 years. That is the nearest star. Everything beyond it multiplies. Any civilization attempting to reach Earth from another star system faces every single constraint we have just described. With the same physics, the same radiation, the same fuel problem, the same impossibility of light speed. The distances do not care whose technology is being applied to them. This is the most honest and complete answer to the Fermi paradox. The question of why. In a universe this old and this vast, we have never detected another intelligence. Perhaps they exist. Perhaps thousands of civilizations are flourishing right now in this galaxy alone. But the distances function as a perfect quarantine. Not because anyone built walls, because the universe simply made space too large and time too indifferent for anything biological to cross it intact. If you are finding this more interesting than terrifying, subscribe. We do this regularly. Take the questions that sound simple and follow the numbers to where they actually lead. There is one final layer. When we look across the galaxy with our telescopes, we are not seeing the galaxy as it is. We are seeing it as it was. Light takes time to travel. A star system 80,000 light years away appears to us as it existed 80,000 years ago. The light reaching our telescopes today left that system when the Neanderthals were still alive. So if our descendants locked onto that system and launched a generation ship aimed directly at it, they would not be traveling toward a location. They would be traveling toward a very old photograph. During the million years it takes the ship to arrive, the galaxy will keep rotating. That target star will no longer be at those coordinates. It will have moved. And it may not even exist. It may have exploded 500,000 years ago, and the light from that explosion hasn't had time to reach us yet. We are aiming at ghosts, blind for a million years, hoping that when we arrive, something survivable is where the math from dead ancestors predicted it would be. And this is the part nobody is willing to say plainly. The Milky Way cannot be crossed, not with better fuel, not with stronger shielding, not with generation ships, not with any technology that operates inside the laws of physics as we understand them. Every solution creates a new constraint. Every constraint compounds the others. The shielding makes the ship too heavy. The fuel to move the heavy ship adds more mass. The generations needed to survive the journey destabilize the mission itself. The communication blackout removes any external correction. The point of no return arrives before anyone expected. And underneath all of it, the distance sits unchanged, unmoved, indifferent to everything we try. We are a grain of sand inside a continent, and we want to walk to the other coast. If any part of this has genuinely stopped you, if you had to sit with a number for a moment before moving on, consider supporting this channel with a super thanks. Every contribution directly funds the research and production that goes into breaking down questions like this properly, without shortcuts, without comfort. Here is the question we will leave you with, and we genuinely want your answer in the comments because this is where the real debate lives. If scientists announced tomorrow that a ship could cross the Milky Way with only 285 years of crew time, knowing that everyone you have ever loved would be dead before you were halfway there, knowing the descendants of your great-great-grandchildren would be the ones to arrive, knowing you could never return, and no message you sent home would be answered in your lifetime, would you board that ship? And do you think the people born on that ship 3 generations later would even want to finish a mission that was never theirs? Drop your answer below. There is no wrong answer here, only an honest one. The stars are not destinations. They are evidence of a scale we were built to admire from a distance. And maybe that is enough. But maybe the most human thing about us is that we will spend eternity refusing to believe it.